If there's one thing I really hate, it is the purposeful misrepresentation of data. And I have seen an increasingly disturbing trend of organizations and groups purposefully misrepresenting data or using data to come to false conclusions to further their own agenda, their own causes. So I want to talk about this because I'm seeing it a lot in my home country. I'm Canadian, and if you don't know, currently in Canada, there is a wave of protesters who are opposing our current public health mandates. Now, I'm not going to talk about the validity of these protesters or the validity of their cause. I want to talk about how data is being used to skew the image of these individuals. So, these quote unquote protesters have spurred a lot of organizations to conduct polls that lead to statistics like 65% of Canadians agree with the statement, "I am frustrated with the current public health restrictions." Then these organizations will use a statistic like the 65% to make a leap in logic to then say something like the majority of Canadians agree with the protesters, or the majority of Canadians want the mandates to be done now, or they want them gone now. Making these leaps in logic to further their own political agendas when the data doesn't actually show that. So before we get into that, let's start with what really is required for a statistic to be used and to really be valid. So first off, you have to know the context for the statistic to have any meaning. A statistic without context is like a letter without a word. Like, it's a letter, it's there. It can mean so many different things, or a word without the sentence structure around it. The structure is what gives meaning to it. The context is what gives meaning to a statistic. For example, I'm sure we all know the statistic that more vending machines kill people every year than sharks. That's true. However, people often violently shake vending machines, which then flatten them when they fall over. If most people violently shook a shark when they met a shark, sharks would have a much higher fatality rate than vending machines. So just because the statistics show that vending machines kill more people or even have a higher death rate, it does not mean that vending machines are more deadly or that they are more necessarily dangerous on a day-to-day encounter. Second, a statistic needs to be appropriately scaled in its presentation. Let's take this ad from Chevy. Now, by all means, this ad makes it look like Chevy is the best choice for buying a truck. It looks like it's going to be much more long-lived than its competitors. However, at an appropriate scale, we can really see that Chevy is about the same as them all. They're all over 95% still on the road. They're all good vehicles, but Chevy wants you to buy Chevy trucks, so they're going to do what they can to skew it to promote Chevy. Third, you cannot make incorrect assumptions about the data and then use that to come to a conclusion. A famous example of this is correlation and causation. It's often said that correlation does not equal causation. Now, this is true. Just because two things are correlated does not mean that one causes the other or that they have really any cause in common. A really good example of this is when the city of Ottawa was building the Rideau Canal, and they would hire workers from down south to come and build it. And they could really only do that in the summer because in Ottawa, summer is really the only good time for building anything. So when the summer would come, the workers would arrive, and then they would notice both malaria and ice cream sales would rise. And the data made it look like the ice cream was causing malaria. But in reality, the ice cream was almost completely unrelated from malaria. The only reason ice cream sales went up was because there was nice weather and it was summer. And the reason malaria went up was because it was nice weather that construction could be done. And some of the people who were doing construction happened to be carrying malaria, and mosquitoes would then spread it. The ice cream and malaria were, for all intents and purposes, unrelated. Now, back to the current situation. Using this criteria, we can see how the 65% statistic in the way it's being used is incredibly misleading and can be quite detrimental. First, an assumption is made that a frustration with the restriction and supporting them as medically necessary are mutually exclusive. They aren't. Spoiler alert. I am quite frustrated with the restrictions. I don't like them, but I recognize that they are important to protect our most vulnerable people. I understand that they are medically necessary, but I don't like that they're in place. I don't like that I have to do it to protect others and to protect myself, but it's a fact of life at the moment. And second, all sorts of false conclusions are drawn. Just because someone is frustrated with the restrictions or that they don't like the restrictions does not mean that they want them gone prematurely. There are plenty of things that we don't like, but we do anyway. You may not like it, but you still have to pay your taxes. I didn't like Shakespeare in high school, and I'll be honest, I still don't really like it now, but I still had to read it and do reports on it. I don't like mushrooms, but I don't have a temper tantrum every time someone says that they like mushrooms or that they think mushrooms are a good part of their diet. So just because someone doesn't like the restrictions doesn't mean they want them gone prematurely. It's very much like trying to tell what kind of a graph I'm talking about by telling you that it goes to the point 0, 0. Okay, I did this in the last video, so if you've seen it, you got a leg up. If not, I'm going to tell you one thing about a graph. It goes to the point 0, 0. That's the origin. Now I want you to tell me what graph I'm talking about. Okay, I'm going to give you 5 seconds. Pause the video if you need longer. Okay, 5, 4, 3, 2, 1. So there are an infinite number of possible solutions. There are an infinite number of graphs that go through the point 0, 0. It's impossible to tell which one I was thinking of. Okay? Here, I'm going to list out just a handful of possibilities of the graphs I could have been talking about. So I could have been talking about just the graph x. I could have been talking about x squared, x cubed, sine x. I could have been talking about x squared, sine x, cos x. I could have been talking about ln x plus 1. All of these graphs cross the origin, but there are an infinite number of others. So short of random guessing, you would never be able to get what graph I'm thinking of because there are an infinite amount. Similarly, if you don't understand the context behind a statistic and you make false assumptions, then your conclusions will be skewed and misleading. Granted, a lot of groups do this deliberately because they use statistics as a tool to get what they want. For example, with the Chevy ad again, they're using statistics and scale to get you to buy Chevy trucks. Now, ultimately, that isn't a big deal. Buying Chevy trucks over a Toyota truck, really, who cares? It's not a big deal. From the data, they're all reliable trucks. It really doesn't matter. And in the long run, it's still a useful vehicle and it will serve your purposes most likely. Worst comes to worst, you sell it and then buy the other brand, right? It's not the end of the world. Where it does become a problem is when this misleading data is used to form public policy, public health policy, and it has a profound, deep, and sometimes and often devastating impact on the everyday lives of people. Now, unfortunately, there isn't much you can do to stop people from spreading poor, misleading data. The best thing you can do is to arm yourself with the tools of critical analysis to be able to deconstruct and find when data is misleading and when it is good quality data, and when the statistic, when the graph is good. And hopefully you can use that to protect yourself and your friends and your family. So whenever someone presents a statistic, they present a chart, a graph, check their source. That's really important, and make sure the methodology of that source is accurate. I once saw an article where it used an Instagram poll as evidence that millennials don't want to buy homes. Completely no methodology at all. That is not a reliable statistic at all. And also check, what are their ulterior motives? What do they want from you? What do they want? And check if the data falls in line with that. And if it does, you may want to be suspect. Do more information. I recommend question everything. That's what I do. That's how you build a strong scientific mind, is to question the data you're presented with. But then it's also important, the other part of that is to avoid falling into conspiracies, is to accept information once you've done your research, once you've read through a number of proper academic studies and papers, that you can accept that, okay, this is true, or this is a good statistic, whatever it may be. So if you've watched this far, I want to say thank you. Maybe consider hitting that subscribe button. Helps out a ton. Share with your friends and family. And, together, if we all start understanding how data works and how it's misrepresented to manipulate us, then we can start fighting back against it. But again, subscribe, like, comment, let me know what you think. Helps out a ton, and I will catch you next time.